Weird little thing, but they don't like roots in the denominator. I personally believe it's because they think they're going to grow weeds. If you have roots in the bottom, they're probably going to grow weeds. So we want to pull those roots out, okay? So that's a way to remember it, is you can't have any roots where? In the bottom, on the bottom. Well, how do I get rid of it? I'm going to pull it out. Well, how do I get rid of a root of 2? How do I make something irrational be rational? If it's a teenager, you just wait 10 minutes. Okay. So we're going to make something irrational rational. How do we actually make an irrational value be rational? Times it by the same root. What's root of 2 times root of 2? What's root of 2 times root of 2? Root of 4, which is 2. It's root of 2 times root of 2 is root of 2e. It's 2. It's 2. Never mind. Okay, so root of 2 times root of 2 is 2. Everybody agree with that? Root of Simeon times root of Simeon is Simeon. Whatever's under the root, if I multiply it by the same root, what will happen to it? It comes out of the what? Root. It went from being irrational under a root to being what? Rational, out of the root. How did we do it? We multiply it by itself. Okay? We multiplied it by itself. But if I do that to the bottom, what do I have to do to the top? The same thing. So I'm going to multiply the top by root of 2. So this is 3 roots of 2 over what? 2, and we're good. That's the answer. That's simplified. In order to simplify, all we got to do is make sure there's no root on the what? Bottom. Okay? Here we go. Try this. All right, what should I do? Cube root of the whole thing. Can I break it into the cube root of top versus cube root of bottom? Yes, that's the first step. I'm going to break this into cube root of top over cube root of bottom. Oh, I should have done, oh well, that's okay. Okay. Do I care that there's a cubed root on the top? Don't care. Top doesn't matter. I just don't want weeds growing in the bottom. Can't have a root in the bottom, right? No root in the bottom. How am I going to get rid of that root? Well, I got to times it by something, but I don't know what yet, because I haven't got it what yet? Simplified. So simplify it before you try and get rid of it, okay? So 81 is what? Now, if this was a square root, could I just bring that 9 out? Yeah, but this is a what? Cubed root, so I've got to bring out a 3, but it's going to leave what? A 3 under the root. Okay, so factor treeing is the key here still. How about the x's? Can I bring the x out? Nope. There's not 3 of them. Okay, and then how about the y squared? Can't bring it out. I got what? Got to leave those 2 in there because there has to be a triple. There's no triple. Can't bring it out. Okay, so the only thing that came out really was a what? Was that triple of 3s came out. Okay, but I still have a root on the bottom. Remember, this is just the denominator. How do I get rid of that stuff? With a cubed root. I've got to multiply it by what? Cubed root of what? What if I put 3? How many 3's will I have under the root? 3 times 3 is 9. But I'll only have how many 3's? 2 3's. How many 3's do I need to bring one out? I need 3, so I don't want to multiply it by, and you were on the right track there, memory. If it was a square root, you're totally right. But because it's a cubed root, I need 3 3s, and I've only got what? How many do I have under the root, though? I only have 1 3 under the root. I need 2 more 3s under the root. What's 3 times 3? I need a 9. Everybody see that? I'm going to need a 9. Because I need how many 3s under the root to bring it out? And have no more root on the bottom. Remember, your goal is to have no root on the bottom. 0 root on the bottom. That means I got to get rid of the entire root. Okay? How many x's do I have on the bottom currently under the root? I have 1 x under the root currently. How many more am I going to need to bring it out of the root? 2. So I want to do x what? How many y's do I have currently under the root? How many do I need? I need 3, so I need 1 more, right? So I'm going to multiply by a y under that root. If I do that to the bottom, I've got to do the same thing to the what? To the top. So this is going to be cubed root 9x squared y. Okay. What's the bottom going to end up being then? 3. I'm going to bring out another 3. How many 3s? Another 3 comes out, but there was already 1 in front. What's 3 times 3? 9. So in the bottom, I'm getting my bottom done first. I have 9 so far. That 3 that came out times the 3 that was already out when I simplified. So I've got 9. How many x's? There was 3 x's, but they were under a cubed root, so therefore it comes out as just 1 what? X. Just 1 x. And how many y's? 1. Just 1 y. Have I simplified the top yet? No. Could I multiply 12 and 9? You could, but is that going to be a heck of a lot of good? What are you going to immediately do after you multiply it? Factor tree it down to a 12 and a what? And a 9. So don't do that. That doesn't make much sense. Let's just factor tree it down. What's 9 going to be? 3 and 3. What's 12 going to be? 3 and 4. And 4 is?
2.
How many do I need to bring 1 out? 3 of the same. Do I have 3 3s? Yes, I can bring out a 3. Can I bring out a 2? How come? There's only 2 of them. They have to stay under. So 2 times 2 is what? 4. I'm going to leave that 4 under the cubed root. Okay? How many x's are under both roots? There's 4 total. How many do I need to bring 1 out? 3. So I'm going to bring out 1 x and a triple, right? And how many x's are left under? 1, because there was 4. I brought out the triple as 1. I leave the other x under there. How many y's are under right now? Total. There's 11 total, right? 3 would go into 11 how many times? 3 with how many left over? 2. So I have y 3 and then a y 2. Everybody with me on how we got all that? Am I done? Not quite done. I'm going to have to reduce, simplify, right? Because the entire question said simplify. So I got to simplify. Can I reduce the 3 and the 9? Yes. What if this was a 4? Could I reduce the 4 and the 4 if this was a 4? No, you can't reduce outside to inside. Okay? It's like Republicans and Democrats. Can't be, reducing one with the other. They got to stay with their own. Okay? So we got 3 into 9 goes what? 3. X's divide out. We have 1 x top and bottom. This y will divide out one of these y's. Will it divide out any of these y's? No, those are the Democrats. We don't talk to them. All right, when we end up with what on the top then? Y squared. What do we end up with on the bottom?
3.
Just a 3. There was nothing under the root to divide out the top part of the root. So I have cubed root of what? 4xy squared. That's my answer. Unsimplified form. Last part. Conjugates. We've talked about them before. Do you remember what they are? What's the problem with simplifying this one? Can't have roots where? On the bottom. And I have actually not even a single root, I have a binomial of roots on the bottom. How am I going to turn an irrational binomial into a rational number? Not even a binomial anymore. How will I turn an irrational binomial into a rational number? I got to multiply it by another binomial. What type of binomial? The conjugate. I'm going to multiply by the conjugate binomial. What the heck is the conjugate binomial? It's written exactly the same, but an opposite sign. It's really what you would get if you factored a difference of what? Squares. Think about that. If you factored a difference of squares, it's the same as a conjugate with two binomials that are exactly the same, but have an opposite sign between them. Opposite sign between them. Why do I want that? Because when I multiply it out, what's going to happen to all the irrational roots? They'll become rational. They will? All those roots are going to go away. They will. It's like magic. Okay. I mean, mathematicians are pretty much magical. They turn irrational things into rational things. It's pretty cool. Because we are very rational people, unless we're crazy, which we are. So, we're not that rational. However, we can turn irrational things into rational things. Obviously. What's square root of 3 times square root of 3?
3.
What? You're telling me these two irrational things multiplied together become a rational thing? I wish it worked that way in real life. I had two irrational teenagers at the same time. They never once turned each other into rational people. What the heck? Thought for sure that would work, but it didn't. Square root of 3 times square root of 3 is 3 because square root of Simeon times square root of Simeon is Simeon, right? It just comes out of the root. All right. What happens with the outside terms? Well, all right. This is where it gets a little weird. Square root of 2 times square root of 3 is square root of what? 6 plus square root of... Hey, you said that was going to go away. It will. Calm down. Calm down. Simeon, don't get mad. Multiply the inside, Simeon. What do you get?
Minus square root of 6.
You do! What the heck? What's square root of 6 minus square root of 6? Goodbye. See you later. Not going to happen. All right. Then what do we get there? What's square root of 2 times square root of 2?
2.
Positive times a negative is a minus. Don't forget the sign. And then 2. Well, 3 minus 2 is... The whole bottom is just... What the heck? Am I done? I multiplied the bottom by the conjugate, but I have to multiply the what? Top by the conjugate. Okay, I got to multiply the conjugate up here. Square root of 3 plus square root of 2. Okay? Now what? What does the top become? Can I distribute that too? Yes, but it's like distributing to an x and a y because they're not like what? Terms. So I really end up with what? This whole thing equals 2 roots of 3 plus what? 2 roots of 2. Can I multiply outside to inside? No, you can't mix the Democrats and the Republicans. You can't multiply the outside to the inside. Everybody got it? That's how you rationalize the denominator. Okay? Pretty easy. Okay, here's the assignment. This assignment is beastly. Keep recording. The assignment is beastly. It's page 197. You're going to do 8 through 89, 4K plus 1. 8 through 89, 4K plus 1. Yeah, you can stop recording.